In this lecture, we are going to evaluate the real integral of the form integral 0 to 2 pi f of sine theta cos theta d theta by contour integration. That is, first we will convert the real integral into complex integral, then we will apply the Cauchy-Residue theorem. For that, let z equal to e power I theta, that is polar form of the complex number. We know that e power I theta is cos theta plus I sin theta. Let it be equation number 1. Now 1 by z is nothing but e power minus I theta, so which is equal to cos theta minus I sin theta. Let it be equation number 2. Now add these two equations, that is 1 plus 2. Then what you may get? Z plus 1 by z equal to, now add these two, then what you may get? So these two will get cancelled. Then you get 2 cos theta. So z plus 1 by z is 2 cos theta. Similarly, find 1 minus 2. So that is z minus 1 by z. Now if you subtract, then what you may get? So these two will get cancelled. Then you get 2i sin theta, which is equal to 2i sin theta. Further, from this equation you get cos theta equal to z square plus 1 by 2z. Similarly, here sin theta equal to z square minus 1 by 2iz. Now, if you differentiate 1, that is z equal to e power I theta. If you differentiate, then what do you get? dz equal to e power I theta I d theta. Since the differentiation of exponential function is exponential function itself. So from this, d theta equal to dz by iz, because e power I theta is z. Now substitute these things in the given integral, then we will convert the real integral into complex integral. So we will see some problems based on this. So now write the problem. Evaluate integral 0 to 2 pi d theta by 13 plus 5 sin theta by contour integration. First substitute the solution. Let z equal to e power I theta and d theta equal to dz by iz, and sin theta is z square minus 1 by 2iz. Before that, let the given integral be I. That is I equal to integral 0 to 2 pi d theta by 13 plus 5 sin theta. Now substitute these things in the given integral. Then what you may get? Integral d theta is dz by iz, dz by iz by 13 plus 5, and sin theta is z square minus 1 by 2iz, z square minus 1 by 2iz. Now the limit 0 to 2 pi will become integral over c, where c is mod z equal to 1, that is unit circle. Now simplify this, then what do you may get? Integral over c dz by iz by 13 plus 5 z square minus 5 by 2iz Now take LCM and simplify. Then integral over C dz by iz by 13 2s are 26 iz plus 5z square minus 5 by 2iz. So this iz and iz will get cancelled. Now this 2 will go to the numerator. Then you get 2 times integral over C dz by 5z square plus 26 iz minus 5. So let it be integral over C f of z dz, where f of z will become 1 divided by 5z square plus 26 iz minus 5. So this 2 also multiplied. This 2. Remaining thing I am taking as f of z. I already told we are going to apply the residue theorem. For that we need to find residue. To find residue, we need to find the poles. The poles of f of z are 5z square plus 26 iz minus 5 equal to 0. So this is a quadratic equation in z. We know that the quadratic equation ax square plus bx plus c equal to 0 has the roots x equal to minus b plus or minus square root of b square minus 4ac by 2a. So here a is 5 and b is 26i and c is minus 5. So substitute, then what do we get in the quadratic equation? So z equal to minus b, so minus 26i plus or minus square root of b square. B square is 26i square minus 4a is 5, c is minus 5 by 2a. So 2 into 5. So minus 26i plus or minus square root of 26 square is 676 and I square is minus 1. So minus 676 minus, so minus of minus plus, and 4 5s are 20, 5s are 100 by 10. If you simplify further, then what do we get? Minus 26i plus or minus square root of minus 576 by 10. Square root of 576 is 24 and square root of minus 1 is I. So minus 26i plus or minus 24i by 10. So there are two roots, that is minus 26i plus 24i by 10 and another one is minus 26i minus 24i by 10. Now simplify further, then what you may get? So minus 26 plus 24, that is minus 2i by 10 and minus 26 minus 24, so minus 50i by 10, that is minus I by 5 and minus 5i. So here both are simple poles. I already told here C is a unit circle. So unit circle, and in the unit circle minus I by 5, minus I by 5 lies inside, minus I by 5 lies inside and minus 5i lies outside. we need to find the residue for the poles which are lying inside. So write it once again. Therefore, the poles are z equal to minus I by 5 and minus 5i, which are simple poles. That means poles of order 1. Moreover, the pole z equal to minus I by 5 lies inside the curve mod z equal to 1. Similarly, the pole z equal to minus 5i lies outside the curve mod z equal to 1. Now we need to find the residue for the pole which are lies inside. Here z equal to minus I by 5 is the only pole lies inside. We know that the residue of z naught is limit z tends to z naught, z minus z naught, f of z. So this is the residue formula. Now we need to find residue at z equal to minus I by 5. That is residue at minus I by 5, which is equal to limit z tends to minus I by 5, z minus of minus plus z plus I by 5 into f of z. So f of z is what? 1 by 5z square, 5z square. This one f of z is 5z square plus 26 iz minus 5 plus 26 iz minus 5 plus 26 iz minus 5. So before applying the limits, first we factorize this quadratic thing. So what you may get? So which is equal to limit z tends to minus I by 5, z plus I by 5 into 1 divided by, if you factorize this, then what do we get? So 5 times z plus I by 5 into z plus 5i. Now this 2 get cancelled. Now what do we get? 1 by 5 into minus I by 5 plus 5i. So which is equal to 1 divided by 5 into, so that I also common, then 25 minus 1 by 5. So 5 get cancelled. Then what do we get? 1 by 24i. So this is the residue value. And now we know that the Cauchy residue theorem is, we know that the Cauchy residue theorem is integral over C f of z dz equal to 2 pi I into sum of residues. This is the residue theorem. Now we need to evaluate the complex integral. This complex integral over C f of z into dz. Okay, now we need to evaluate this one. Already 2 is multiplied. So now I will become I equal to 2 times. And then we are going to apply Cauchy residue theorem to evaluate this integral over C f of z dz. So 2 times 2 pi I into sum of residue. We have only one residue here, so which is nothing but 1 by 24i. So now simplify this, and this II also get cancelled. So finally we get 5 by 6. This is the record integral value. So this is the value of this integral. Integral 0 to 2 pi d theta by 13 plus 5 sin theta. Thank you.